Hello everyone, welcome to my very first video blog. Today I want to talk to you about scalability of databases, particularly what happens when your database does not fit in memory. And the three basic databases we're going to put under test today is Trino, DuckDB, and a very recent member of the family, Apache Fusion. My name is Thomas Kaiser. I go by the Database Doctor on LinkedIn, and I've been working with databases my entire life, and I love testing them and seeing how much I can squeeze out of them. For those of you who might be interested in Databricks and Spark, I've written a blog about that. There'll be a link just below, and go and check that out. Even if you are on Databricks, you might still find what I'm about to say really interesting. I hope so, at least. And let's first think a little bit about what it is that's consuming memory in your databases. There are basically three main memory consumers in a database. The first one is joining, that you're hopefully all familiar with, combining two tables to make a new stream. Then we have aggregation, that's what you get when you say group by, or if you want distinct values. And the final one is sorting, which is what you get with things like order by and window aggregations. Those three contribute to most of the memory used by your queries. So it is very important that those operations are highly effective in a database because they form the basis of all the other scalability that you're going to get. And the way we're going to test that today is we're going to use a tried and tested dataset, TPCH, but we're only going to use two tables from it because that's all we need. The first one is going to be line item. The version we're going to use has 150 million rows. That's a very small database by most standards these days. But it's also nice because you can run these tests on a laptop. In fact, I'm going to provide all the details you need to reproduce this test right here in the repo that I'm sharing online. The other table we're going to use is orders. And unlike a line item that we're going to keep at 150 million rows, we're going to vary the size of orders depending on what test we are running. We're going to start at 1.5 million rows and we're going to go all the way up to 30 million rows. So that's the basic setup we're going to run today. And we are almost at our little improvised lab. So let's get outside and start hacking away at this. There we are. Welcome to the outdoor lab. It's a beautiful day here in Estonia today. And just to remind you, we're running DuckDB, which is written in C++. We got Trino written in Java, and we got DataFusion written in Rust today. We are going to put each of these engines in their own docking containers, and we're going to run it on my Apple Silicon, that's right next to us here, which is ARM64. If you're going to run these tests at home, make sure that whatever Docker container you're running runs on silicon that's available to your host computer. Don't do any form of emulation, for example. I made that mistake on the first run. Let's have another look at that Docker container. I'm going to give it a total of 7 gigabytes of memory. 1 gigabyte we reserve for the actual executable of the database so that it could keep its internal data structures there. We have a 4 gigabyte TempFS RAM drive, which contains the Parquet files that we're going to read. That's how we're going to minimize the time we spend on doing I/O. And then we're going to enforce a 2 gigabyte limit on the queries we run. Exactly how that limit is enforced depends on the engine we're running, and I'm going to put that right there on the screen so you can see how you do it on Trino, DuckDB and DataFusion. Now the idea of the test is that we're going to keep increasing the size of orders from a small size where it fits in memory, where our reservoir is not full yet, until we reach a point where the database has to use disk to run the query. And this is what I'm illustrating here with my poorly drawn waterfall. The disk we're going to leave unlimited. The database can use as much disk as it wants, but we are going to cap it on its memory usage in this particular way. Here we are, our first query. We're joining line items with orders. And as you might recall, line items is scaled to 150 million rows. We're going to keep that the same for all our variations of scale. And orders, we have built a special table per scale. And you'll see that there's this really odd join criteria here. And what this is just doing is that it allows me to use the same line item table and then map the keys in that line item table into a much larger space, depending on what scale I want to run for orders. So it's just a simple little trick, and it doesn't actually have much of an impact on the runtime of the query. I tried with materialized tables, doesn't make much difference. The other thing that's interesting here is that why am I not just counting the rows? Well, if I only count the rows, the database doesn't actually have to look at very much data. It could just look at the keys, and it would be able to calculate what the count is. We want the database to read all the columns in orders, and we're forcing it to do that by counting the order columns. And that allows us to create a much larger hash table for the join, which allows us to quickly push towards the scale limit of the 2 GB memory ceiling that we have. The way these tables are laid out, we are getting somewhere in the range between 150 to perhaps 200 megabytes per scale. So in the case of the scale we're looking at here, which is scale 4, we'll be sitting around maybe 800 megabytes. So we should expect to hit the memory ceiling just around scale 10 by design of this test. There's a lot to see here. DuckDB and DataFusion do very well compared to Trino in terms of runtime. In fact, DataFusion even beats DuckDB at certain scales. But as we get closer to the memory ceiling, first we see DuckDB take a big jump in runtime, and we see the same thing with DataFusion and Trino. And DataFusion and Trino simply refuse to run the query when they're forced to go to disk, whereas DuckDB just keeps running. There's another interesting data point here, which is that you'll notice that there's this bump in the curve with Trino. I'm running all the queries 3 times, and I'm taking the best timing. But Trino is all over the map in terms of runtimes, and this is something we're going to talk about when we look at the other queries as well. Here's our aggregation query, and we only need order scale at this point, no need to join anything. And the problem we will have with this query is we can't just do a simple order by and send the rows back to the clients, because that would just measure the network traffic it would take to move the rows. So instead we have to be a little bit more clever about it. Order by with a limit can be optimized in ways that don't force the database to sort the entire stream, so that's not going to work either. So what we're doing instead is we are forcing an ordering via a window function. And that has the effect of having the database order all the rows. We're using a partition key that allows the database to nicely parallelize this problem. And then we just take a count, or sort of a sum, of all the row numbers. It's a nonsense query, but it is a query that will force the database to actually do an ordering of the entire orders dataset. And here are the scale numbers for the sort. This looks a lot better. All the engines are now able to run the query. DuckDB and DataFusion are very tightly in the race here. You'll notice that Trino still has a big jump as we start approaching the scale ceiling, and we see the same large difference between the Trino runtime and the DuckDB and the DataFusion. Not much else to see here, really. Sorting is perhaps one of the most well-studied problems in computer science, so we shouldn't be surprised that the engines are capable of doing this. And finally, we have the aggregation query. This one is quite simple. We are selecting from order scale again, projecting out some columns and grouping them. This will force the database to either sort or hash the entire stream. And because we don't want to send all the rows back to the client, we do the same trick that we used in the join. We just count the columns, and that's how we're going to force the database to use a lot of memory without measuring network traffic. And here's the aggregation results. Again, we see DuckDB and DataFusion running a very close race, with DuckDB pulling ahead at the lower scales, but DataFusion actually doing really well at the high scales. And again, we see that Trino pays the Java tax. It's significantly slower. Something else happens with Trino here. I am sometimes able to run scale factor 12, 14, and 16, and sometimes not. It depends a little bit on whether I have restarted the Docker container before I run the query, and what queries have run before it. And I guess that tells you why databases that need to be high speed and have consistent response times, don't use garbage collected languages. Today we tested 3 different database engines. Of those 3 engines, DuckDB was the only one that managed to run all the queries we threw at it. DataFusion did a pretty good job, kept up with DuckDB on performance for most queries, but when it came to running joins that were larger than memory, it ultimately refused to run the query. Trino, it paid the Java penalty. It was significantly slower than the 2 others, and also refused to run queries when under memory pressure. At FlowDB, we're building a distributed ad hoc query engine. And that means that we want to be able to run any query you throw at us, really. And to do that, we got to be very good at memory management. We were hoping to build on DataFusion, but it looks like there's still work to be done there. DuckDB does seem promising, but DuckDB, at least for now, is a single system database. It lacks the distributed query planner, and it lacks the distributed execution engine. I don't think we're going to take anything from Trino. But we will continue hacking, and we will continue building, and we will keep you up to date with it, either through these video blogs or from our blogs on the website. And until next time, I will see you right here from the Lake House.